Hello everyone, my name is Alexa Gonzalez, and today I will be talking about the cybersecurity aspect of Hummingbird's AI application called Guacamole ID. As for my contribution to this team, I had the pleasure of working with Felipe, who is one of the developers of Guacamole ID. Through periodical communication, I was able to present to him some of the vulnerabilities based on the topics he would assign to me for research. Before I start this presentation, I want to make sure that I inform you that I decided to omit some of the things just because of time constraints. To start off, I will be talking about Python and its code security and code protection that it offers through different features, including libraries. The reason for this is because when we started working with this company, they were using Python as their programming language. Later on, I will be talking about C++, which is what they're currently working with. I will be talking about Python as if the person reading was a beginner. So essentially, Python is a interpreted, all-tech oriented, high-level programming language with dynamic semantics. What does this mean? What this means is that Python source code is not directly translated by the target machine, but by the interpreter, which reads and executes the code. So unlike functional programming, which is building software by composing pure function, Python actually is organized as a software design around the data, which is why it is called an object-oriented programming language instead of function and logic. In this case, an object can be a data field attribute with unique attributes and behavior. So some of the important features that Python offers are actually the modules and the packages, which it uses to provide the program with some sort of modularity and code reuse. So what this means is that you could split up a large programming task into separate, smaller subtasks that you could later reuse in different code without having to go through all the lines of code that you've already written. Basically, Python's debugging process is fairly simple because there is no compilation step. However, there are exceptions presented to the developer. There are a couple of characteristics that Python would be useful in coding applications such as that of Guacamole ID. And to talk about those, I will be talking about some of the tools that help improve code security and data security. Python has ways to implement those using sanitizing external data, scanning the code, and deserializing. So when it comes to sanitizing external data, any application can be vulnerable to injection, including cross-site scripting, because of the use of external data. In order to understand the severity of this attack, it's very important to understand what they actually are and how they work. Essentially, an injection attack is basically a malicious code in the network which fetches all the information from the database to the attacker. Similarly, a cross-site scripting attack is a type of injection in which the malicious scripts are injected into the trusted websites. Essentially, it's really important to be aware of all these attacks when you're using Python because they could be prevented, and a way to do this is by always sanitizing your data. So just basically removing any sensitive information from external sources, whether it originates from a user input, a website, a database request. It's very important to always sanitize data as soon as it enters the application so you don't come across insecure handling when you're dealing with sanitation. It is very recommended that you check the input before handling the exceptions. And two Python libraries are actually very recommended for this. One of them being Schema and Bleach. So basically, Schema is a Python library that validates Python data structures, including data structures obtained from configuration files, external files, command line parsing, and others. Bleach just basically allows host-based HTML sanitizing library that escapes or strips markup and attributes. And so basically, you could use a template engine to gather the capabilities and provide auto-escaping to prevent cross-site scripting using markup safe. Another way to provide sanitation is also by preventing data from being used to command And another way to do this would be to scan the code, which is just basically a way to make sure that you maintain pattern security by using static code analysis tool to inspect the code that has already been written. Another concept of Python that is important to understand is capsulation, and this allows for the necessary and relevant data to be exposed to the outside world. In essence, there are a lot of features and concepts that Python offers that could provide code security. It is tricky to ensure that the code is protected at all times, but just knowing the proper techniques and the proper knowledge certainly makes it easier. The next topic is dynamic link libraries, and their vulnerabilities. And again, this is just intended for beginners. So just to give you a bit of background, a dynamic link library is a collection of smaller programs that larger programs can load when they need to complete specific tasks. When a program is ran, it has to be compiled from the source code, which is basically human readable code that the program turns into an executable file, which is a binary code or machine code that the computer can read. During this process, multiple files are linked to one of those, and it is known as a static or dynamic file, and they correspond to their link libraries. So, of course, we do have some challenges. We have DLL hijacking or DLL injection, which is when a threat actor inserts a malicious .dll file in the path where a legitimate .dll file would be expected to load. This causes the main application to load the malicious DLL file with the executable. So long story short, the hacker finds the name of the .dll file, replaces the name, inserts the malicious DLL file, and then they have access to that device. Apart from this, we also have a DLL preload attack, which is another vulnerability that one can confront when working with DLLs. What happens during a DLL preload attack is a hacker gains control of one of the directories, and they can force the application to load a malicious copy of the DLL instead of the DLL that it was expecting. The consequences of this is that the attacker can execute code in the context of the user who is running the application. So far, we can see a pattern, and it is basically that the vulnerabilities can pop up in any programming language, in libraries, and now in frameworks. So when it does come to Qt, it is a software development framework, and Qt offers a commercial license, which makes it legal to prevent modifications, reverse engineering. However, the open source license does not prevent this, and reverse engineering is just basically the act of dismantling an object to see how it works. This is important to understand because if you are trying to hack something, you want to be able to see the mechanics of it. You want to see how it works, and you want to be able to do this. And one way to protect the applications from this is by utilizing static linking, which just prevents the simple swapping of Qt binaries used in the application, which then causes reverse engineering to become even more difficult. So with static linking, it allows the application and the Qt libraries to be combined into a single binary, and if a hacker would want to hack this for any reason, they would have a harder time compared to the dynamic linked application. Then we have APK, which is just referring to the Android package kit, and it is an extension for the Android package files that are used for distributing applications on Android OS from Google. So there are some vulnerabilities when it comes to this. One of them could be the hard-coded credentials, the weak cryptography, and insecure storage. And the second to last topic is the Qt, QML, and C++ vulnerabilities. So in terms of C++, the second order SQL injection and the resource injection would be particularly important for Guacamole ID to be informed about. A second order SQL injection occurs when the user supplied data is stored by an application and later incorporated into SQL queries in an unsafe way. In order to detect this particular vulnerability, it is necessary to submit suitable data in one location and then use some other application function that processes the data in an unsafe way. Typically, for this to be done, the hacker has to perform at the line, because the hacker performs the attack on the backend functionality without having any prior knowledge of the system. To protect from this, you can use an approach that's just basically allows you to disallow by default and just allow any data character that has to be allowed by explicitly enumerating them. A resource injection consists of changing resource identifier used by an application in order to perform a malicious task. And so this type of vulnerability is important to take care of because an attacker could gain access to modify sensitive data or system resources. A way to avoid this is by undertaking an accept known good input value validation strategy, meaning that only acceptable inputs that conform to strict specifications are allowed. And so it's important to differentiate front-end security and back-end security vulnerabilities because typically a company will only focus on the back end and not so much on the front end, but they are equally important because think about it like this: if you leave your door open to your house, it's not very likely that anybody will come in, but if they do come in, they will have access to your entire home. That's kind of how it works. As for the back-end security vulnerabilities that Guacamole ID could face, one of the examples could be an OS command injection, which is classified as a web security vulnerability that allows an attacker to execute arbitrary operating system commands on the server that is running an application and compromising the application and all of its data. The last topic that I did want to show was a PowerPoint that I created that has to do with the desktop vulnerabilities. And so basically there are 3 types of vulnerabilities: the injections, the broken authentication and session manager, and the security misconfiguration. Here we have a DLL injection, and it just basically shows you the process of how it works. We have the broken authentication and session manager, and again a diagram of how it works. And finally, security misconfiguration, and again a diagram of how it works. There are ways to protect from this. One of them is routine scans, one of them is limited access, and also using the kernel mode and being able to work from the kernel mode. And that is it for the cybersecurity aspect. Thank you so much.